right, geometry. We are kicking off the 23-24 year with algebra. One lonely unit that we didn't quite get to cover at the end of last year. It is all on square roots. It's not an easy one, but it's what we're going to start with. So there you go. I am getting through your entrance exams. I will have them back to you Friday. So you can have the weekend to start to work on any practice work, and then retakes will start next week, Monday, and I'll be at school Monday and Thursday until 3:30, just like last year. Okay, so I can simplify radical expressions. This unit focuses on the R in perm dogs, those radicals, also called roots. And so radical expressions are any expressions that contain a radical. Okay, we've dealt primarily with square roots. We will dabble a little bit with cube roots and fourth roots and fifth roots, just so you know what they are. But our primary study is going to be with radicals. And the experience you've had with these before, if you think all the way back to pre-algebra, your 6th grade year in PO12, you learned how to evaluate them, which is simply, what's the answer? What is the root of 36? 6. And why is it 6?
Because 6 equals 36.
The definition of a radical is what times itself equals, in this case, 36. Chase? And that would be 6 times 6. Right? What is the root of 121? 11. Because 11 times 11 is 121. Okay? Where square roots come from is, if you have a square with side lengths of 6, what is the area?
6.
Thus why it's called a square root or a perfect square. If you have a square with side lengths of 11, what is its area? 121, right? That's kind of where this comes from. Then last year in CO2, we went to estimating, to where I gave you a non-perfect square. So the root of 19, you can't evaluate it. There's no rational number times itself that gives you 19. So instead we estimate it. And walk me through the process of how you would estimate this, the root of 19. Andrea.
I know, what that root, or with 19, with 2 roots in between. So 4 and 5, so you find out 16 and 25, and then you make the estimation.
Right. Yeah, this is why it was important for us to learn our perfect squares, so that if we see the root of 19, we know it's between two perfect squares, the root of 16 and the root of 25. Why is that helpful? Because we know that root 16 is 4. We know that root 25 is 5, right? Meaning that root 19 is between 4 and 5. But is it closer to 4 or closer to 5?
4.
Closer to 4. How do you know?
Because it's 3 different other than 6 different.
Because it's closer to 16 than it is, that's a horrible arrow. It's closer to 16 than it is to 25. That means it will be closer to 4 than it is to 5. So a good estimation, I would accept 4.1, 4.2, 4.3, even 4.4. Would not accept 4.5. It's clearly closer to 4 than it is to 5. But again, it's just an estimation. Okay? What would the root of 200 estimate to be? And remember, you could not use a calculator on this test for this very reason. You can't just punch it in and read what the calculator says. You have to kind of know those perfect squares.
Can you use it on this test?
You will be able to use it on this test because we're not doing this. Okay? But what is the root of 200? Estimate. What two perfect squares is it between?
10 and 20.
That's a pretty big.
That's a pretty big
Great.
one.
14 and 15. The root of 14 squared is 196. 15 squared is 225. So it's between 14 and 15. And what would you say?
14.3.
14.3 would be fine.
Stop using your calculator.
14.2, 14.1. Okay, somewhere around there. Nick.
Would you accept 14.4?
I would accept 14.4. It's not, but yeah, it's necessary. Lastly, root 44. 36 and 49 are the perfect squares. 36 is 6. Root 49 is 7. And so what would your estimation be?
6.7.
It's closer to 7 because 44 is closer to 49 than it is to 36. So 6.6. 6.7, 6.8, 6.9, anywhere in there. Okay? So that's what we've done with roots up until this point. We've evaluated them, we've estimated them. Today, and really what 61 is all about, is how to simplify them, which is not the same as estimating. Okay? Kids will go into a test with their calculator and they'll just type in root 45 and put whatever decimal pops up. What is the thing that simplifying does that estimating doesn't? Like, think about things you've simplified in the past. When you simplify a fraction, you simplify a variable expression. Kayla.
It's usually the same answer, just like in a simpler form.
Okay. Colin? Something to add?
It's more accurate.
More accurate? Okay. When you simplify a fraction, are you changing the value?
No.
No. Right? 4/8 and 1/2 are still the same value. They're still 0.5. When you simplify an expression, when you take 8n plus 3n and write it as 11n, whatever n is, these two things will still be the same. You're not changing the value. When you estimate something, root 19 is not 4.3. It's close. That's not what it is. You changed the value. So our goal with simplifying these is to not change the value of the roots. Okay? Which is why you can use a calculator, because you're not just plugging it in and writing the decimal, but there are calculators out there that will simplify it for you, and that's why you can't use those. So, how to simplify a square root? What you're looking for, there's a mathematical property that allows you to take a square root and separate it into a pair of its factors. So we can take the root of 45 and we can rewrite this to be the root of 3 times the root of 15, or the root of 9 times the root of 5. I think those are the only two. Okay? But what we're looking for is the factor pair that contains a perfect square. And of those two choices, which one are we going to go with? Which one has the perfect square? The 9 and the 5, right? We don't want that one. And the reason why we want the 9 and the 5 is what can we do with the root of 9?
It's already a perfect square, so it's easy.
Yeah, what is the root of 9?
3.
3. We can do something with that, right? We can't do anything with the root of 3 or root 15 because they're not perfect squares. We're just as helpless as we were with root 45, but with root 9, we can change that into a 3. Because root 9 and 3 are equivalent values. And even though root 5 is not a perfect square, we can't do anything with it, that's okay. Our final answer is going to be 3 times the root of 5. Now, those with the calculator, I want you to take that calculator, I want you to calculate the root of 45. Kind of take a look at whatever nasty decimal it is. It'll be like 6.7 or so. Okay.
708203932.
Thank you. And now, take the root of 3 times the root of 5, and
Same thing.
it's the exact same thing.
Yep.
Okay? That's how on a test you can use a calculator to help prove to yourself you've done this correctly. These two things should have equivalent decimal values, because when you simplify, you don't change the value. Now, those higher end calculators, the 84s, the 89s, etc., they'll do this for you. They'll cut out the work and go straight there. That's why you can't use them on this test. But you can use a calculator to compare decimal values to see you've done it correctly. Andrea.
This might be like a little ahead, but if I have two radicals in my equation, can I just combine them?
Yes.
Combining them? So,
But
if
we
I
will get there, yes.
So it would, from 2 radicals, it would just become 4.
Yes. You combine with multiplication. Yeah. Maddie.
So what do you do if your calculator does it for you?
Then you can't use that on the test. So you would be another one that is, you'll have to get a different calculator for the test. Okay. That'd be a great one to use on the homework, just check your answers, right? Because homework is practice, but for the test, they'll need a different one. Root of 20. We've got some options. We can take the root of 2 times the root of 10, the root of 4 times the root of 5. Which one's got the perfect square?
2, 4, 5. 4, 5.
4 and 5. Right? The 2 and the 10 are not helpful. Neither of those are perfect squares. We can't simplify either of them. What is the root of 4?
2.
Equals 2. The root 5 just drops down. And so 2 root 5 would be our answer. Okay? Root 700. Give me some factor pairs of 700. Caitlin.
Square root of 100 and square root of 7.
Okay, we can use root 100 times the root of 7. Any others that we can use?
50.
50 is not a perfect square. That'd be 50 times 14. Now those are very helpful. How many times does 25 go into 700?
Too many. 28.
28 times. So we could use the root of 25 times the root of 28, because that does have a perfect square factor. What else could we use? There's one other pair.
50.
50 is not a perfect square.
20.
20 is not a perfect square.
2 is.
2 is not a perfect square. What times itself is 2?
Sorry.
4.
4 is? How many times does 4 go into 700?
Too many.
Lots.
175.
175. So in this case, there are a couple different factor pairs that we could use. Let's start with root 100 times root 7. What do we do? Simplify the root 100 because that's our perfect square. What does it become? It becomes 10. So then we've got 10
Times the square root of 7.
root 7. Can we do anything with root 7? Do we care? No, we're done. Okay? Move on. Root 25 times root 28. What does root 25 simplify to be? 5. Why is this going to give us a different but yet same answer? Nathan, you see where I'm headed with this? I'm asking it very cryptically, but
Why do we have to do this?
why do we have to do the whole concept in general?
Yeah, because couldn't you just plug it in into your calculator instead of doing that?
So again, and we've talked about this before, right? All the formulas that are done for you, at some point, somebody had to write that program initially, right? And when AI takes over and they shut down all our access to the computers and the technology that we enjoy, we better have people that know how to do this by hand.
That's why we have
Otherwise, the machines will.
consume us and we will die. That's why we have.
Well, like,
I would still have to
What if
plug
I'm
that in my
compromised?
calculator. Well,
Then we steal your brain. We'll steal your brain.
Okay.
Watch your video.
But here's what I'm headed with this. Okay, let's say we've got the fraction 8/16. Okay, and I tell you to simplify that, and you say, okay, I'm going to divide by 2 and divide by 2 and 4/8.
It's just a half.
Did you go far enough?
No.
No. What can you do now?
A little more.
Oh, I'll divide by 2 again. 2/4.
One half.
No,
Divide by 1.
you want to go all the way to 1/2, right? Can you get from 8/16 to 1/2 in one calculation?
Yes.
Yes.
8.
But why did it take us 3?
Because we wanted to check.
Because we didn't use the greatest common factor to start with. If we had divided each of these by 8 initially, which is the GCF, we would have gotten to 1/2 in one step. However, we divided by 2, divided by 2, divided by 2. We got there, but not as efficient. Is 25 the largest perfect square that goes into 700? No. That's why. If we don't use the largest perfect square, I look at that 28. What can I do with that 28? Is it a perfect square?
No.
Does it have a perfect square factor?
No. Yeah.
Yeah.
4.
4 and 7, right?
Oh. So then
Right?
you just get to
My
10
my
seven.
root 25, I can still simplify that, but my root 28, right? That's got root 4
But
times
then
root
you
7.
do the solve for the square root of 4, which is 2. Then you multiply 5 and 2 to get
No,
10,
I
which is
did
the
not
same
get
as
that.
7.
Oh, they
So-
just said seven
Why
root though.
Can you speak
Right.
English and
What?
So,
I don't have that
Yeah.
answer.
Yeah.
Find the root of 4, so it's 2, and then you multiply it by 5, and then you get
Oh,
10
okay, I get it.
times-
I get it.
I
Thank you
don't.
for speaking English.
I'm really
So then
dumb.
you
my
just
bad,
basically,
Paul.
so then basically you just do
So-
the same as 107.
If you don't use the largest perfect square, which we didn't, 25 is not the largest one, 100 is, you run into this situation where that other factor can also be simplified. And in this case, what we did was we simplified root 28 by writing it as root 4 times root 7, because 4 times 7 is 28, right? That root 4 is a perfect square that equals, that's where that 2 came from, right? And then multiply the 5 and the 2 gives us our 10, and what we're left with, that root 7, matches here too. So if you're not using my point of this is that you're not using the largest perfect square, you might go from 8/16 to 4/8, which you're not done yet. You can go further, and you have to be watching out for that. Root 4 times root 75, same situation. Root 4 is a perfect square, it gives us 2, but what can we do with the root 175?
Destroy it.
Destroy it, how?
25.
25 and
I don't know.
You just keep getting back to the same answer.
7.
25 and 7, right? The root of 175 can be simplified to be the root of 25 times the root of 7.
And
The
then
root of
get
25
2 times
being-
5 is 10.
And where does 5 come from?
The square root of 25, getting you to back to the 10 and the square root of 7.
Yeah, root of 25 equals 5. And we're right back to where we kind of were here. 2 and 5 combine to make the 10. And then we have the root 7. Okay? My point is, always be looking for that largest perfect square to simplify with. Otherwise, you might not go far enough, or you create extra work for yourself. Not the worst thing, but, you know. Nathan.
You have 363
Yeah.
twice.
Do I?
Yeah.
Spirit of Christmas, you're welcome. Or actually, no, that deserves the first button. No. There we go. Yeah.
Thank you. Can we like cross out one of them?
No.
No, do it twice. See if you get the same answer.
I wonder. Well, we just kind of proved it with the 700.
So root 72. What factor pair are we using, or should we use, to be most efficient with root 72? There are a couple
Two
options
ways.
out there.
Oh my goodness.
Square root of 9 and square root of 8.
I wanted you to say that. Thank you.
I'm done.
Root 8 and root 9, is it valid to use? Does it have a perfect square in it? Yes. Is it the largest perfect square that
No,
goes to
sir.
72?
No.
It is not.
18.
What's the largest perfect square, Colin?
36.
36 and 2. Okay. Could you use 9 and 8? Yes, you could. The root of 9 is 3, but what can we do with that 8? With what? 4 and 2, right? Whereas this root 2, there's nowhere we can go, else we can go with that. Root 2, there's no other perfect square factor that goes into 2. So in this case, root 36 giving us 6, and then the root 2, that gets us to simplest form in one step. Root 9 times root 8, this would be 3 times root 4 times root 2. The root 4 equals a 2, and we do end up to our 6 root 2 anyway in the end, but it's a little bit extra stuff. Whatever floats your boat. Yeah,
I
Hazel.
just noticed that for 700, for most of the questions, the answers usually have something to do with the equation on the top. So like 10 times the square root of 7 is like, oh, never mind.
No, are you saying that like 10 times 7 is 70 and then times another 10 is 100?
Yeah.
That's because root 100 is the same as 10 times 10. Right? So we keep the 10 root 7, right, as our final answer. But we got that 10 from the fact that 100 is 10 times 10. So there is a connection there. You're not wrong. Okay, I'll even throw you that button there. Okay. Yes, Edward.
How do you do the
Fractions. Let's. Are there any other questions on this part first? Anyone run into any that they are? And please use your calculator. Calculate the root of 72, and then calculate 6 root 2. Make sure your decimals are the same. This is another one of those things on the test where you can just hand it to me and tell me what your score is, right? Because you can check them very easily if you take the time. Going on down to fractions. Ooh, look what comes next. Variables. But fractions first. There's another mathematical property that allows you to disassemble a fraction, the root of a fraction. Anyone have any guesses? Maddie? We're not going to turn it into multiplication. But the root of 27/16 is equal to the root of 27 over the root of 16. Which is nice for us because what do we like about especially the denominator, the root of 16? Oh, that's nifty. Root of 16, we can take it separately. That equals 4. And do we know what to do with the top? Simplifying, no, Nathan. Simplifying root 27.
With 9 and 3.
Root 27, we can simplify that to be root 9 times root 3. It's really the same thing. I mean, you have root 27 right up here, right? Root 9 times root 3, the root 9 becomes 3.
And then that other one's 3.
And then the other one stays root 3. And so our final answer is 3 root 3 over 4. Okay, so don't let fractions scare you. You're basically just doing it twice. Only in this case, you'll notice, Spirit of Christmas, every denominator is already a perfect square. If they're not, that's PO61 part 2.
Doing the next.
We're not going to go on variables today, no.
So
One of the
biggest-
one of the legitimate
Yeah,
biggest complaints on my rating last year was I would teach too quickly and cover too much too fast. So I'm trying to slow it down.
Let us go! Hey, let's teach.
No.
You teach too.
So it's only the front page?
No, you teach too fast.
It's great. Yeah, I think it's great.
Your
fast.
your homework for tomorrow is the full sheet. Only this first page though. Don't go on to variables.
Sure.
Make sure that work. Oops. Nathan, Andrea. Make sure that your work is shown. Okay. Showing work is required. I need to see your steps. Don't tell me I did it in a calculator, I checked in the calculator. I hope you do check it, but I need to see those intermediate steps. This work here would be the intermediate steps. That's the work that I need to see. Okay? Tomorrow you will have a bell ringer with 5 questions from this page. The idea being, if you do this and understand it, all you have to do is look at your answer, look at the page, select the correct option, and then go on with your day. However, if you don't get 100%, which being a homework check, remember is 4 out of 5, then you can retake that up until 8 p.m. tomorrow night for full credit. But these are those freebie points that parents get really annoyed if you don't have all your freebie points when it comes time for conferences or the report cards. I don't check homework on accuracy, I check it on completion, but you've got to give me the effort. Okay? All right.
Yes, sir, Cap.
Thank you.
El Capitan.
Mr. Schultz?
Yeah.
You're on track for all 5s this year.
Thank goodness.
Huh?
I'll try and not get bad.
Well, just keep going this speed.
Perfect.
Great.
Any other questions, comments, concerns, complaints, comments, congratulations, or criticisms? Yes,
Hi,
Nathan.
Stanley.
Yeah, no, he's perfectly fine. He's not bothering anybody. Anything else? Okay, do we remember the outro?
Don't
Hit the like and subscribe.
That's good. That's good. I say that's how you math. You say that.
Don't
So here we
forget-
go. That okay. That's how you math.
Don't forget to like and subscribe.